Good afternoon. In today's lecture, we'll talk about alcohols. Alcohols are a class of organic compounds which is characterized by the presence of an OH group directly attached to a carbon atom. And they're one of the most important classes of organic compounds because, as we'll see, they can be created from many different organic compounds and they can also be transformed into many different organisms. So they're really a crossroads of organic synthesis. Alcohols derive their name from Arabic words al-kuhul, which mean the essence of wine, because the Arabs they realized that the inebriating component of wine has certain special properties, and they call that alcohol. Many alcohols are used in everyday household use. Ethanol, of course, is a component of many alcoholic beverages. Isopropanol is another example, which is used frequently. And these and other alcohols are, first of all, important in household use, but also hugely important in industrial feedstocks. So this is really a vastly important class of compounds. In terms of the structure, as I said, alcohols are characterized by the presence of an OH group. That OH group, the oxygen of that OH group is sp3 hybridized and has a tetrahedral structure. And therefore, they are sort of resemblant of the structure of water. In water also, we have two electron pairs. These electron pairs cause a certain repulsion, which then compresses the angle between the two hydrogens. So this is just 104.9 degrees. But as we go from water to methanol, or the simplest alcohol, that compression is reversed. So now this angle is again 108.9, relatively close to the tetrahedral angle, because the metal group simply needs space to expand. Okay? Alcohols are classified typically based on the type of the carbon that bears the OH group, the hydroxy group. So these, where the carbon is primary, an example would be ethanol, are so-called primary alcohols. Then there are secondary alcohols. An example would be isopropanol. And finally, there are tertiary alcohols. Such as T-butanol, where the OH group is attached to a tertiary. One needs to really disclose that at this point we will not talk much about compounds that look like this. I call it phenols, although they look like alcohols because the OH group is attached to an sp2 hybridized carbon of the aromatic ring. These behave very differently. Their acidity is different, a lot of their chemistry is different. So we will touch upon them in this lecture at several points, but we will not really go into details much. But suffice to say that phenols are oftentimes considered separately from alcohols because they are quite different.